Today we're covering growth and decay graphs when dealing with exponential function. So here in the middle, we have a table where the left column are example of a growth function and the right column are examples of a decay function. So let's take a look at the growth functions. Now, when we're dealing with exponential functions, it's usually in the form of b to the power of x, where b represents the base. Now, the absolute value of the base, if it's greater than 1, then the orange graph, as you see at the bottom left, that is an example of a growth function. And here are 3 examples where our base, the absolute value of our base, is greater than 1. So here we have the whole number 4, that's obviously greater than 1. Now if we take a look at the decimal value, 3.215, that is a decimal number that is greater than 1. And then lastly, let's take a look at the fraction, where it's 7/2. If the numerator is greater than the denominator, then the fraction is greater than 1. So these 3 examples, a whole number, a decimal, and a fraction, all greater than 1, then their graphs will be similar to the orange graph shown on the bottom left. Now for the decay, the absolute value of our base, if it's between 0 and 1, but mainly less than 1, then the graph will be just like the blue graph at the bottom right. So here I have 2 examples. One is the decimal number and the other one is a fraction. So for the decimal number, 0.791, that is less than 1. And then for the fraction, 3/4, if the numerator is less than the denominator, then the fraction is less than 1. So when you have a decimal number or a fraction that is less than 1, the graphs will be very similar to the blue graph at the bottom right. So when we're dealing with graphing exponential function, you need to know which way it's going to be. For example, at the bottom left, the orange graph. When you're looking at the graph from left to right, it starts from the asymptote and then it will increase as you move along towards the right. Now, if you're looking at the blue graph at the bottom right, when you're looking from left to right, you're going to start up top and then it will decrease as you move along towards the right. So pay very close attention on the difference and the similarities between these 2 graphs. So again, to review, for the growth graph, the orange one, if you start from the left and go to the right, it will increase. For the decay graph, the blue one, if you start from the left, it will, and then start from the left, and then go towards the right, it will be decreasing, as you can see from the graph. Now let's move on to the standard b to the x, its y-intercept, and its asymptotes. So this is the information you need to have when graphing exponential function. So a standard exponential function, b to the x, the y-intercept is always going to be at 0, 1. And the asymptote is y = 0. So it's an invisible line or a dashed line where the graph does not cross y = 0. Now let's talk about when you have a number with the x. So on the bottom left, we have b to the power of x minus m. So when you have a number that is minus m, then it will affect your y-intercept. So for the y-intercept, it's going to be 0 plus m and then comma 1. So the minus m will affect the x value of your y-intercept, but the asymptote will stay the same, y = 0. Now if you look at the right side, b to the power of x plus m, then for your y-intercept, it's going to be 0 minus m, comma 1. So when you have x plus m, you will affect or change the x value of your y-intercept, but the asymptote will stay the same. So make sure you follow these rules because these information will help you graph your exponential function when you have a number with the x minus m or x plus m. And I'm using m to represent any numbers that we have. Now let's take a look at the other types. So on the left side, we have b to the x and then minus p, where p represent any numbers. So if you have a function where it's b to the x and then minus p, then the y-intercept is going to be 0, comma 1 minus p. So when you have a minus p, that means that it will change the y value of your y-intercept. So it only changed the y value of the y-intercept. In addition, the asymptote will also change, where it's going to be y equals negative p. So when you have a number subtracted after the x or outside the x, then it will change the y value of the intercept, and the asymptote will also change, and it will equal to what number you have. So if it was minus 3, then my y-intercept is negative 3. If it was minus 7, then my asymptote will be y equals negative 7. On the right side, if you have b to the x and then plus p, for your y-intercept, it will be 0, comma 1 plus p. So if you have a plus p, then it will change the y value of your y-intercept. So I repeat, it will change the y value of your y-intercept. In addition, it will change your asymptote, where it's going to be y equals p. So if you have, for example, plus 2, then my asymptote will be y equals 2. If it was plus 12, then my asymptote will be y equals 12. So as long as you have the information when it's minus p or plus p, then our y-intercept will change, more specifically the y value. In addition, our asymptote will also change compared to the standard exponential function.